Hi everyone, welcome back to my number sense series. In this video, we're going to be talking about something that's very, very important, not only in number sense, but also just in math beyond. This is something called base conversion. And this is not going to be our first video on base conversion because it takes a little bit of time to learn. But first of all, what is a base? Well, a base is kind of a property of how we do math. For example, we count in base 10. And what does that mean? Let me show you. Let's consider this number, 1,234. What is the value of this number? Well, to understand the value of this number, we're going to have to draw on a concept that we probably learned in maybe like 3rd grade or 4th grade, place value. Now, place value is, exactly what it sounds like. This digit has a value of 10 to the power of 3. This has a value of 10 to the power of 2, 10 to the power of 1, and 10 to the power of 0. Together, they make 1,000, 200s, 3 10s, and 4 1s, 1,234. This is a base. This is a property of a number system. And this is the really important part. We want to learn how to convert between different bases. So what would a different base look like? Well, for example, consider this number, but in base 6. That's what the 6 down here means. In base 6, what would this be? Well, in base 6, this would have a place value of 6 to the power of 3. This would be 6 squared. This would be 6 to the 1, and this would be 6 to the 0, which is still 1. This would be 1 times 6 cubed, plus 2 times 6 squared, plus 3 times 6 to the power of 1, plus 4 times 6 to the power of, 6 to the power of 0. This would be 1, 2, 3, 4 base 6. And the important thing is that this is 1, 2, 3, 4 base 6 converted into base 10. For example, 6 cubed here would be 216. This would be 72. This would be 18 and 4. If you add them all up, you get 310. And so what we've done is we've converted something from the base 6 system into our base 10 system. And to do that, we look at the place values. The place value is what gives a number values. And so if we want to convert between bases, we have to think about what is the number that is in each of those place value slots, basically. And so this is 1 in the 6 cubed slot, 2 in the 6 squared slot, 3 in the 6 to the 1 slot, and 4 in the 6 to the 0 slot. And all combined, this, when you add them in base 10, so these are now base 10 numbers because we've converted them into base 10 values, they would give you 310. So what we would write this as is 1, 2, 3, 4 base 6 equals 3, 1, 0 base 10. These two values are equal. And likewise, you can convert 3, 1, 0 base 10 into 1, 2, 3, 4 base 6, but that is topic for a different video. Now, one more thing to know with bases is what values values can actually take. For example, in base 10, we can have this digit be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But we can't have it be 10, right? We don't write 10 in a digit slot. When we start counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, we don't, keep using one digit forever. When we get to 10, we have to go into a second digit. And so that's also another way you can think about bases. What's the highest you can count before you go into a new digit? So we can't have a 10 in one of these slots, just like how you can't write a 6 in any of these slots, because if you wanted to write a 6, you would just go to the next digit. And similarly, you can't have a 7 or an 8 or a 9, because those will require more than one digit, so they can't fit inside a digit slot, if that makes sense. So in base 6, you would only be allowed to use the digits 0, 1, 2, 3, 4, and 5. Someone who counts in base 6 wouldn't even know that 6, 7, 8, 9, and 10 really exist as digits as we understand them. Now, with all that said, let's get some practice with converting other bases into base 10. That is what this video is about. So, 576 in base 8. Once again, let's just refresh ourselves. What does this mean? What are the values? What are the place values? Well, let's see. This is the rightmost digit, always has value 1 because it is our base to the power of 0. So this would be 8 to the power of 0. Then this would be 8 to the power of 1. So I'm going, from right to left. This would be 8 to the power of 2. Okay, so then when we want to convert this into base 10, we have to just, find the value of this entire digit, because the value of this digit isn't 5, it's 5 times 8 squared. Just like how the value of this digit isn't 1, it's 1,000. So this is 5 times 8 squared plus 7 times 8 to the 1 plus 6 times 8 to the 0. 8 squared is 64. 5 times 64 is 320 plus 56 plus 6. This would give you an answer of 382. That is, and in number sense contest, you would write it in a blank that looks like this. So I'm writing base 10. So you would write 576 base 8 equals 382 base 10. That is what we've, proven. So next question is going to be something similar. And once again, notice that we're only using small digits because we can't write 4 or 5 or 6 or 7. We're restricted to the digits 0, 1, 2, and 3 because we are in base 4. So, not much is different. It's really the same drill. So this has a value of 4 to the 0, 4 to the 1, 4 squared, and 4 cubed. So let's just add them all together and see what we get. This is a 1 times 4 cubed. So this is the value of the first digit. 1 times 4 squared, the value of the second digit. 2 times 4, the value of the third digit. And a 1 times 4 to the 0, the value of the fourth digit. And so total, this would be 64 plus 16 plus 8 plus 1, which is equal to 89, of course, in base 10. The only reason 4 cubed we write as 64 is because we're operating in base 10. If we were operating in, base 9, we'd write it as 71 instead. Now 321 base 5, once again, the same idea. Add up the values of all the digits, and to find the values of the digits, think about the place value and the value that you've put into that digit slot. So for example here, the value of this place is 5 squared. This is 5 to the 1, and this is 5 to the 0. So 3 times 5 squared plus 2 times 5 to the 1 plus 1 times 5 to the 0, that would be 75 plus 10 plus 1, which is equal to 86. Of course, in base 10. So once again, in contest, what you'd be writing is, you'd be given this blank with a base 10 at the end. And that's how you know you should convert to base 10 as opposed to, some other base. And you would say 86. So, yeah. Now, our last question is something with a special base. This is base 2, also known as binary. You might know that our computers kind of think in base 2 because ons and offs, ones and zeros are really easy for our computers to think about and easy to physically represent with, lights and stuff. So this is base 2 called binary. And what's special about base 2 is that you only use ones and zeros, as I've said. And so this is very convenient for some things, very convenient for computers, but not so convenient for us humans. But if you want to do something like computer science in the future, you still have to know how to use base 2 and then base 16 especially. So base 2 is something that number sense is going to especially test you on. And if you get to the higher levels, even like multiplying and dividing in other bases. So this is going to be a taste of our other video. But how do we work in base 2? Well, don't be scared. It's really just the same thing as the other bases. So this has a value of 2 to the power of 0, 2 to the power of 1, 2 squared, 2 cubed, 2 to the 4th, 5th, and 6th. So, you can see again how far memorizing your exponents gets you. It's also really helpful for base conversion. So if you haven't done that, please memorize your exponents. So this would be 2 to the 4, 2 to the 5, 2 to the 6. So the value of this place is 2 to the power of 6. And now notice that our next digit is actually 0. And so no matter what base we are in, if we see a 0, the value of that place is 0, because it doesn't matter what this is. 0 times anything is 0. So we skip it. 1 times 2 to the 6 plus 0 plus 1 times 2 to the 4th plus 1 times 2 to the 3. Then once again, this is a 0, so we're going to skip the 2 squared place value plus 1 times 2 to the 1 plus 1 times 2 to the 0. And this is our final expression. So you can see in base 2, naturally, when you represent numbers, they get longer, but not necessarily harder. So we have 64 plus 16 plus 8 plus 2 plus 1. And in the end, this is all going to give us 91 in base 10. So this is an introduction to base conversion. This is an explanation of what a base is. Think of it as an alternative number system where instead of stopping our digit at 9, we stopped it at somewhere like 7, and then we just had to deal with it. So this is a video where we cover how to convert from other bases into our bases. Our base, base 10. In future videos, we're going to talk about converting from base 10 into other bases, maybe even adding in different bases, and converting between other bases, like converting from base 2 to base 4, base 8 to base 2, things like that. And you'll see why it works especially nicely with 2, 4, and 8 in the future. But all of that is for the future. Hopefully this has served as a nice introduction for you. Really try to understand this video because it's going to be very important for the rest of bases, which is a huge part of number sense and math. So I hope this video was helpful to you guys. Thank you guys for watching, and I'll see you next time.